So let's have a look at verifying solutions to differential equations. Now in this video I'm just going to have a look at a second order differential equation. I'm going to have a look at a solution and verifying that that is in fact a solution to that second order differential equation. First of all, let's just have a look at what a differential equation looks like. I'm going to have a look at a first order differential equation that will look something like this. Let's say 2 dy dx is equal to 7y. So this is a first order differential equation because it has a dy dx in it, and it is differentiating y once, if you like, so it's just dy dx. A second order differential equation will look something like this. It'll have a d squared y over dx squared in it, dy dx here, and let's say that's equal to something like 7y. So this would be classed as a second order differential equation because it has a second differential of some function y in it. This one also has a first differential, and it has the function here 7y as well. Okay, so that's what first and second order differential equations will generally look like. Let's just have a look at what we mean by solving one of these. So let's have a look at a quadratic equation, for example. So let's take x squared plus 5x plus 6 is equal to 0. Normally if you solve this, you'll get something like, you'll do this kind of thing here. So you put an x there, 3, 2, and they'll add to give you 5. So you'll end up with x is equal to minus 3 or minus 2. So you'll have two specific solutions that will work for this particular equation. Now when we solve differential equations like these ones here, we'll end up with a function that's a solution, not an individual value like this, but an actual function, or indeed a class of functions, a certain type of function that will actually work for these type of equations. So we would just put the function in here, we would differentiate it once and put whatever we get in here, differentiate it a second time and put whatever we get in here, and we should end up with the left hand side equal to the right hand side. So that's the kind of thing we're going to do. So I'll just show you how that works. We look at a specific example of a second order differential equation. Let's have a look at d squared y over dx squared plus 6 dy dx plus 9y is equal to 0. So this is my second order differential equation because we have a squared here, we have a second differential here if you like, and the solution that I'm going to say works for this is my function y is equal to 2x e to the power of minus 3x. So I'm saying this is the solution to this equation here. So let's just verify that it is in fact the solution. So what we've got to do here is we have our y here, so we can put that y in here. We can put 2x e to the power minus 3x here, but we need to differentiate it once and put whatever we get here, differentiate it a second time, put it in here, and we should get 0 when we add these three up. So let's just do that. First thing we're going to do is look at finding dy dx. So we've got to differentiate this function over here. So that will give me, you can see here actually it's a product. You can see you've got a 2x here multiplied by an e to the power minus 3x. So we've got a function of x here and another function in x here. They're both multiplied. So I'm going to apply the product rule here. So let's do that. So it's going to be u dv dx plus v du dx. I'm saying this is u here and this is v here. So it's u dv dx. So it's going to be u, which is 2x, times dv dx. So I've got to differentiate the e to the power minus 3x. So that's going to be minus 3 e to the power of minus 3x when I differentiate it. You need to use the chain rule here, so it's e to the power minus 3x, and then you've got to differentiate the minus 3x as well to give me the minus 3 here. So that's my u dv dx, then it's plus v, which is e to the power minus 3x, and then du dx, which is just going to be 2. So let's just tidy that up a little bit. Here we'll end up with minus 6x e to the power of minus 3x. Over here should end up with just plus 2e to the power of minus 3x. So that's my first differential. So let me just tidy that up again, because I know I'm going to have to differentiate this again. So let's just make it a little bit easier to do. Maybe I'm just going to take out the 2e to the power of minus, I'll take out the 2e to the power of minus 3x. So if I do that here, I'll take it out here first on the right hand side, so that'll give me 1. So I've just divided by 2e to the power of minus 3x here first. Now I'm going to do this one here. So it's going to be minus, well, 2 into 6 is 3, and then we have x as well. So that should be it, I think. Yeah, that should be it. Okay, so let's do the second differential now. So we've got to do d2y dx squared here. So d squared y over dx squared. So again, I have a product here. So I'm going to use the product rule here. So I'm going to take this here as being u. And I'm going to take this here as being v. And again, it's u dv dx plus v du dx. So it's going to be u, which is 2e to the power of minus 3x. Now we've got to differentiate what's in the bracket here, so that'll just give me minus 3. So it's u dv dx plus v, which is 1 minus 3x. And I've got to differentiate the u, so that's going to give me minus 3 will come down here. So, yeah, so that's going to be minus 6 e to the power of minus 3x. Okay, so let's just tidy this up a little bit. So it's going to be minus 6 e to the power of minus 3x. That's the first part. And here I'm just going to take these two here and multiply them out. So it's going to be plus minus 6e to the power of minus 3x. Minus minus is plus, and that's 3 6s, 18e to the power of minus 3x, and there's actually also an x there as well. I'll just put that in here. So it's going to be minus 18 x e to the power of minus 3x. Okay, let's just tidy that up a little bit more. Let's see, we've got minus 6 e to the power of minus 3x, minus 6 e to the power of minus 3x, plus, plus 18x e to the power of minus 3x. And again, if we just add these, we should end up with minus 6e to the power of minus 3x, minus 6e to the power of minus 6x, so that's going to be minus 12 minus 12e to the power of minus 3x. Yeah, so, and then first of all I'm going to have this 18. I'll put the 18 first. 18x e to the power of minus 3x minus 12e to the power of minus 3x. And I think finally what I'll do is, no, actually I might leave that as it is. It might be useful just to leave it rather than factorizing out. I was just thinking of factorizing out maybe a 6 and an e to the power of minus 3x. It might be easier just to leave it as it is. So look, I have my second differential here, and I have my first differential here. So I'm just going to substitute those into this equation here. So let me just write that out again, and then I'll do the substitution. So the differential equation, second order differential equation, was d squared y dx plus 6 dy dx plus 9y is equal to 0. So I'm just going to substitute these in here. So the first thing I'm going to do is put the second differential in here, the first differential in here, the actual solution in here, and then equal to 0. So let's do that. Second differential was 18x e to the power of minus 3x minus 12e to the power of minus 3x plus 6 times dy dx. Now the first differential was 2e to the power minus 3x, 1 minus 3x. And then we have plus 9 times y. So the solution was 2x e to the power minus 3x. And we're saying that's equal to 0. So let's see, is it equal to 0? Let's just work all of this out. So here we have 18x e to the power of minus 3x minus 12e to the power of minus 3x. Here we've got plus 6 times, let me just multiply this out here first. We've got a 2e to the power of minus 3x minus 6x e to the power of minus 3x plus, and here we've got 2 9s, 18x e to the power of minus 3x equal to 0. So let's see, we've got 18x e to the power of minus 3x minus 12e to the power of minus 3x plus 12e to the power of minus 3x minus 6 is 36 x e to the power of minus 3x plus 18x e to the power of minus 3x equal to 0. Okay, let's see, do these things cancel out here? Well, let's see, we have 18x e to the power of minus 3x here. We have minus 36 here, and we have another plus 18x e to the power of minus 3x here. So the 18 and the 18 will give me plus 36, and here I'll have the minus 36 x e to the power of minus 3x. So these will give me 0. And here I do have minus 12e to the power of minus 3x, and I have plus e to the power of 12e to the power of minus 3x, so that gives me 0. So I do in fact end up with 0 is equal to 0. So in other words, y is equal to 2x e to the power of minus 3x is a solution. Is a solution. Okay, so we have this solution here. But what you'll actually find here is that any function of this form here, any function, we'll call it, let's say, f of x equal to some constant times x e to the power of minus 3x will actually work. And this is what I meant when I said earlier that it may not only be one individual function that it will actually be a solution. It may be a class of functions or a certain group of functions that will actually work. And this group here will actually work. So if we were to do the same again with this here, you will actually find that it will be a solution to my function y. So let's just run through that just to show that. We have our f of x here. Let's just do f prime x. We'll do first differential. So again, it's going to be a product here. So we have our u and our v here. So this is u, this is v. So it's u dv dx. So the dv dx is going to be minus 3 e to the power minus 3x plus v, which is e to the power minus 3x. And du then is just going to be k. So again, once you tidy that up, you'll end up with k e to the power of minus 3x, 1 minus 3x in here. So this is my first differential. Let's just do the second one then, f double prime x here. Again, this is a product, so you've got your u and v here. This is the u, this is the v. So it's u dv dx, so it's going to be k e to the power minus 3x. V is going to be minus 3. You can see similarities to what we did earlier. So this is u dv dx plus v, 1 minus 3x. Du dx, that's going to be minus 3k e to the power of minus 3x. So that's our u dv dx plus v du dx. Now, if we just tidy all that up, again, I'm going to skip, I'll let you just work through the algebra here, but you'll end up with 3k e to the power of minus 3x into 3x minus 2. So you can just mess around with all of this here yourselves, and you should end up with this here. Factorize out this 3k e to the minus 3x. Okay, so let's put these two. This is my first differential here. This is the second differential here. Let's just put them into our original function. So let's see, what was it? D squared y dx plus, I think it was 6 dy dx plus 9y. Yeah, 9y equal to 0. So let's put them in here. So our second differential here is, I might just multiply this out at this stage. So you'll get, what you'll actually get here is a 9kx e to the power of minus 3x minus 326k e to the power of minus 3x. So that's my second differential here. Now I've got to multiply the first differential by 6. So I'm going to put in the k e to the power of minus 3x. Again, I'm just going to multiply this out and put it in. So it's k e to the power of minus 3x minus 3k x e to the power of minus 3x. And then finally the function itself is going to be multiplied by 9. So it's going to be 9 times kx e to the power of minus 3x. And that's going to be equal to 0. So let's see, do we get 0 when we do all of this? Okay, so we have 9kx e to the power of minus 3x minus 6k e to the power of minus 3x plus 6k e to the power of minus 3x minus 18kx e to the power of minus 3x plus 9kx e to the power of minus 3x, all equal to 0. Okay, let's see what we can get rid of here. Let's see, we've got 9kx e to the power of minus 3x. So let's look at this one first. Kx e to the power of minus 3x. Kx e to the power of minus 3x. So we have one here, and we have one here. Now again, we've got plus 9 of them, minus 18 of them. So these three will cancel. We have plus 18 of them, minus 18 of them, that'll give us 0. Also here we've got minus 6k e to the power of minus 3x, plus 6k e to the power of minus 3x. That finally gives us 0 is equal to 0. So in actual fact, our function, or our solution, y is equal to some constant times x e to the power of minus 3x, will actually work for this particular second order differential equation. So you'll get an infinite number of solutions here, rather than, as I said, in our normal algebraic quadratic equations that we did at the very beginning, we ended up with 2 solutions. And if you have a linear function like 3x is equal to 9, for example, you'll end up with x is equal to 3. You'll just end up with one solution. But in differential equations, you can end up with a range or a class of functions that will actually work.